Okay, so same idea on example 2. We're still finding the surface area of this composite figure over here. It looks like this time we have, what two shapes do we have? We have a half sphere, a hemisphere, and a cylinder, it looks like. Okay, so I'm going to do a half sphere. I know, that's a terrible drawing. And then a cylinder are two shapes there. So we're going to do this one. Okay, so our second question is, what are the surface area formulas for each of these solids? So we know for a hemisphere, and I want to think about the parts. I know at this point maybe you've written down in your notes that a hemisphere is 3 pi r squared, which is true, but let's think about why it's 3 pi r squared. It's half of a full sphere, which is half of 4 pi r squared, right? So in other words, it's basically 2 pi r squared, right? And then you may or may not be thinking about the fact that that normally includes the lid, right? We're talking about this part right there, or this circle part right there on the hemisphere would be an extra pi r squared, right? And then the other formula, the cylinder, is 2 pi r h plus 2 pi r squared. Okay, and so I've written that down here on line B, what the two formulas are for the hemisphere and the cylinder. Our next question, C, write a formula for your composite solid by combining the appropriate pieces of the individual solid formulas. So basically we just take out the parts we don't need is what that means. We've got our two formulas. What parts do we not need? What parts are not touching air? Or if I were to dip this whole thing in paint, if I were to glue the hemisphere to the cylinder and then dip it in paint, what would come out with paint on it and what would be on the inside of the shape and not come out with paint on it? So I hope you're thinking about this circle on the inside a lot. Let's start with the cylinder because that's the easier part, I think. On this cylinder, we have the whole lateral area is being used. And we have the circle on the bottom would be exposed to air, or if you want to think of it as dipping in paint, it would be dipped in paint. But this one on the inside, we don't need the surface area of that because it is exactly that. It's on the inside. It's not an outer surface. When we go to find surface area, we only care about outer surfaces. So we're just going to make this 1 pi r squared. Okay, then for the hemisphere, we know that we're going to need this part of the hemisphere, the 2 pi r squared, but that lid, this part right here, we do not need. That red circle there, again, is on the inside, so we don't need it. So really our formula, our composite formula, is just 2 pi r squared plus 2 pi r h plus another pi r squared. So couldn't we really call this, if this is 1 pi r squared plus 2 pi r squared, we could say this whole thing is the 2 pi r h plus really it's 3 pi r squareds, right? So that would be our composite formula, 2 pi r h plus 2 pi r squared. Now, this problem didn't have in writing that I wanted you to find the surface area, but let's go ahead and do it. Let's find the surface area. So this is the surface area of the composite right here. And so we know, I can't even see the drawing anymore, that our radius is 8. And we know our distance between our circle bases is 2, so that's our height, 22, sorry. And to be honest, that's all we need, right? So we're going to go 2 pi times 8 times our height of 22 plus 2 pi, 3 pi. 3 pi times 8 squared. Okay, and we're going to put that in our calculator. And that comes out to approximately 1,709.03 So I'm just going to call that 1709 feet squared.